Hi, I'm Vamshi, and we are going to discuss about assignment one, machine in the machine learning subject. This assignment is about machine learning basics, and in this assignment, we have three exercises. So the first exercise is a data set inspection. In this exercise, we are going to inspect the data sets, and we need to import we need to load the data diabetes data sets from the sklearn, and we need to plot it using matplotlib. So we are storing the features in diabetes X, and the labels in the diabetes Y, and using diabetes dot load diabetes as a function in order to load the diabetes data sets present in the sklearn. We are printing these dimensions of the both diabetes X and diabetes Y. So we can see it is high dimensional. So in order to we need to convert into a two dimensional, because visual we need to inspect it visually, so we need to convert it to two dimensional. So this is the function PCA is equals to decomposition dot PCA, and then components is equals to 2, as they are two dimensional. So we can see after printing the dimensions it is 2, and using the matplotlib we are printing the we got the total diagram with a scatter plot, which is scatter plot diagram, visual diagram. So you can see the you can see the components here. In the next exercise is label conversion. So we have 442 labels. So we can see the shape of the label is 442. Now so it is a diabetes Y, which is diabetes Y, with diabetes underscore Y in our data set. So we are doing the label conversion because the numerical values we can do only regression, we cannot do the classification. So in order to make it suitable for the classification, we need to convert the labels into binary labels. So here is the conversion method that the question has been given. So we are taking the diabetes average of the diabetes underscore Y, and we are creating a value Y binary, which have only two values, that is 1 and -1, where greater than average gets 1, and the other get -1. Next, so this is the method. So here we have taken the average of the diabetes, and then this is the condition that we have been satisfying to make that categorize into two values, that is 1 and -1. So after printing the Y binary, you will be getting this kind of array where it will be compared with the average and made like this. And then next, visualizing the converted data set. So here we are converting the data sets, and Y binary value 1 would be marked as positive plus, and Y binary -1, that is less than the average value, will be marked as X. So these are the labels, and this is the diagram that we would be getting. So visual inspection of data sets with binary labels. So the next part is exercise 3, which is bias variance trade-off, which is very important, I guess. So next, in this we are not talking about any diabetes data set. So in this exercise, we are generating a one-dimensional data set using these two lines of code, where we will be getting the random numbers from of 1 to 150 with the scale of 2. And next is we are splitting the data X and data Y into training and testing data sets in order to get the test error and the train error. So in order to uh, make the initialize the machine learning model, we are creating our first machine learning model, and these are the so you can we are performing the linear regression here, and we can find the score, we can find the error, and we can find the training error and the test error using the LR dot score, that is linear regression dot score. And next is in this I'll go straight forward into code. Here we implemented the same functions, same lines of code, and we have created a function generate data, which will return the generated data. And here data x comma data y, it will be given with the returned values of this function. And we are printing the dimensions, that is 75 and 75. And we are taking the random package in order to generate the random seed values. And we are training we are splitting we need to split the training data and the testing data. So we are also importing train test fit. And here this is the seed value 42 seed value, and the random dot seed is a seed with a seed included. And next is we are splitting this training and testing using train test split function, which will be test size would be 0.33, because the dimension of this function is 75. So in the question it is given that we need to 50 samples are training and 25 samples are test data set. So we are taken this. And next printing the dimensions of the training and test data. So you can see that training and test data are one dimensional. So in order to be compatible for the sklearn, we are reshaping the training and test data set. So we are replacing the uh, we are creating the we are including one as a dimension in train and test data set, where -1 would be ignored. And we need to check the dimension. So you can see that is there is just one dimension, sorry, 50 comma 1 and 50 comma 1, 25 comma 1 and 25 comma. This is the training data sets, and this is the testing data set. So now the next step is we come to the machine learning model, where we are using a linear regression model. So we have imported the linear regression package, and linear regression function is used, and it has been marked as LR. And we are training the linear model using LR.fit training data set. And we need to print the coefficient and intercept, that is LR dot coefficient and LR dot intercept, in order to get the fit line. And next is so we need to find the train error, and we need to find the test error. So you can find the training and test error using LR dot score the data set included. Then you will be finding the training and test error. So this so next you need to we are going to plot a diagram, plot a graph using this fit line and training and test data set. So this is the uh, total graph, total code for the graph, where we are fitting the line, where the fitted line is with the red color. And so we have already found the coefficient and also the intercept. So that would be enough for the line. And the next is we are in this exercise, we are also going to learn another type of linear regression, that is ridge regression, which is having an additional regulation with an objective function with an alpha value. So with the change of alpha, there will be a change in the line. So in this question, there it has been asked that we will be using alpha under 100 and 1000. So we have taken, so here alpha values are taken into a list 100 and 1000. And the next is we are plotting the graph for each alpha value. Which alpha value will be plotting the line, sorry, linear line, so fitted line. And just these are the line graph things. And this is the alpha value we are iterating from the range of the from range in the length of the alphas. And then so we are printing the alpha value. For every alpha value we are using training the data set, and we are finding the intercept and coefficient, and then we are finding the training and testing error. So for every data set we'll be getting training and testing data set, training and testing error. Then for every alpha value you are going to plot a graph using that particular alpha value. So it's a red, green, and blue are the next one. So for one it is red, and next is green, the next is blue. So in this way you will be finding the fitted lines. So these fitted lines would be useful for our machine learning model. Thank you.